everyone. Like Rob said, I'm Alex Dunn, and we're going to be looking at architecting some Xamarin applications using the Flux design pattern. Um, so we're going to be going over what Flux actually is and why use it, and then we're going to look at an actual Flux implementation in C#, and then we'll go ahead and build a super simple app together from scratch. So some assumptions about this course: this isn't a beginner level course. This is going to be, an advanced architecture topics. So there's an expectation that you know how to build apps in Xamarin. You have some familiarity with Xamarin Forms and XAML and MVVM and the two-way binding system. Some resources. So I have a project up on GitHub with the initial project that we're going to be starting off with today. And then you can also look at a full completed solution that I have there. I also have another video that talks about this topic up on YouTube, and then I've also left here some links for you for the actual Flux documentation and some demos and examples from Facebook. Those demos and examples are not applicable to Xamarin. They're for JavaScript and Facebook's React.js framework, but it can give you an idea for the general design pattern and maybe go into a little bit more detail of ways to scale the pattern out in general than I can go into today. So let's talk about Flux. Basically, Flux is a client-side application architecture and design pattern that was built by Facebook. It's used for building robust data-driven user interfaces, and it has a focus on the flow of data as well as the separation of concerns. Its biggest, strong suit is that its data flow is unidirectional, which is different than a lot of existing design patterns and is what Facebook needed when they were building out their really complex systems. It was originally built for Facebook's React.js framework, so we're going to go into a little bit of detail kind of comparing the two. So if you've ever used the Flux pattern with React.js or with any other sort of Facebook framework, then we're going to be able to kind of compare those two into how it can apply to Xamarin and bringing it over to C#. So for those who are familiar with React.js, there's some important parts that really make a difference in how Flux is applied to it. So you have your component render function, your component state, the component's props, and then the actual component lifecycle, like component will mount, component will unmount, and all that stuff. That's really important for applying some of the event handling and things like that go with the Flux design pattern. So when you compare those to how we can look at something with C#, Xamarin, and MVVM two-way bindings, basically your component render function is what your actual view is. So your XAML or C# page or view. Your component state is what our view model is going to be, so that's going to actually hold the properties that apply to the state of that view. The props for a component are the view properties that we pass in, and the component lifecycle is similar to or relatable to our page lifecycle that we get with Xamarin Forms. Or if you're looking at Xamarin Native, that'd be something like your activity lifecycle or your view control lifecycle for Android and iOS. So Flux is broken down into basically 4 components. There are actions, there's the single dispatcher, there are stores, and then there are your views. So basically the flow that's unidirectional is that an action might do some very small business logic like mapping some models or something like that. It then fires an event from the dispatcher. The stores listen to specific explicitly set events that come down from that dispatcher, and so those will take those events when they fire and actually update data or do some real data logic in the store. And then the views are basically subscribed to a certain set of stores, so when the data is updated in the store, that will propagate down to actually update the UI. So a more realistic structure is one that's still unidirectional, although there's a little loop here. But basically the same thing applies. Our action calls the dispatcher, the stores pick up the dispatched events, the views pick up the changes in the store. But basically once you have an action happen on your view, like clicking a button or maybe hitting the top of a list or something, the view is going to call another action, which then rotates all the way back to the dispatcher, and the data flows right back down to its views. So we can take this structure and apply it to Xamarin and MVVM on top of it. So the same thing, we have our actions to our dispatchers to our stores, but rather than having our views pull directly from our store. We're going to have a separated view model that picks up those changes from the stores. And then the two-way bindings that we set up from our view model to our view is what's going to actually update our UI. And then rather than having a view actually fire against an action, our view is going to fire a command or something against our view model, and then that view model is going to call that action, which goes back to the dispatcher. So that's Flux. It's pretty straightforward from there, but really the more important part is why use this, why go about maybe changing some of your existing application structures, why look at this as an option going forward. Something I like to talk about whenever I talk about design patterns and architectures is that this isn't going to solve all your problems necessarily, but this is another tool you can add to your belt that can help you in deciding a direction for your application to go. And this one, it's really different from existing ones, like just using 2A MVVM or MVC or rolling your own. It really is different in the way it handles unidirectional data flow. So it's cool. So problems with existing patterns, right? So those bi-directional ones like MVC or something like that, is that they allowed for multiple controllers to talk to each other. Data is passed between controllers frequently, or there isn't like a hard set rule on where the data goes once it gets to a controller. So it's pretty straightforward to design an MVC application when your app is small, because you have a small amount of data. It's easy to just keep in mind and keep track. But once that scales to something extremely large, it gets really, really difficult to maintain. So the changes that trickle down from multiple controllers to views become very hard to track, very hard to test. The flow of that data is not defined. And then even from MVC, the general pattern, we've seen multiple implementations that have come out to be very different, where they try to set an explicit set of rules, but they've all kind of gone in their own different direction between something like Cocoa MVC or the ASP.NET MVC or something like that. So how does Flux solve those problems? So it controls the data flow. It's in a single direction. Everything goes from an action to the dispatcher to the store to the view. Then the view kicks off another action, and it all happens the same way. There's really easy trickle-down control for those datas. So it allows for views to listen to changes from multiple stores. So a view isn't just subscribed to a single store. You can have many different stores that data updating is going to update the same view. You can also have multiple stores listen to the same dispatched events. So if you have, for example, a button click that needs to basically handle two completely different sets of data, the button click that actually fires that action is agnostic to what's listening to it. And then two different stores can say, hey, we got that action from the dispatcher. We're going to go update two different sets of data. And then from the other aspect, multiple views can invoke the same action. So the data also has a single point. It's not living in multiple different places. Everything is coming from your stores. So having like a single domain over your type makes it really easy to test where it's going and what's happening to it, rather than having multiple places actually change or affect your data. So another thing that's cool about it is that it can live alongside other patterns like MVVM, which is why I still wanted to show that here. You don't have to use it with MVVM and two-way bindings in Xamarin, especially if you're doing a Xamarin native implementation, where you're not going to have your XAML and your bindings kind of built in for you. But it plays really well with it. And it also plays well with other architecture patterns and stuff like that, like domain-driven design or an onion architecture. And it also works really well with inversion of control and dependency injection. So we're not going to look at using an onion architecture, DDD, or inversion of control in our example, but if you go look at that final implementation that's up on GitHub, I actually do use inversion of control and dependency injection to inject my view models, my stores, and actions and stuff like that. So to talk more about those complex data flows with kind of a visual example, you can have a single action that's called, it doesn't matter where it's called from. You could then have two different stores pick up that action, update their data separately, and then from there you can also have multiple views listen to the same store. So you can see view 1 and view 2 are both going to update based off of changes to store 1. But view 2 is also going to update from the changes in store 2 as well as view 3. And it gets really easy to track where that data is coming from and where it's going to. So another example, a view can call multiple actions, right? So you could have maybe 2 different buttons or something like a list view event or something like that. That's going to call 2 different actions, which then multiple stores can listen to the same one, or the action can be pulled down from the 2 different stores, and then the views again can update based off of multiple stores. So again, here's a link to that final implementation using Xamarin Forms with Flux, MVVM, and inversion of control dependency injection. And we're going to be building an app that functions the same way. It's not going to use IOC or DI because we don't want to overcomplicate it. But we can look at the basic project structure. Like I said, I didn't use any sort of onion architecture or anything really crazy. It's the basic Xamarin Forms XAML PCL template. So we just have the one PCL and then each of our actual platform projects. And to actually dig into the PCL structure, since that's really what matters here, you can see that we have our to-do actions, our to-do action types, which are basically like IDs for our events. We have our store, and for our dispatcher, we're actually just going to be using the messaging center that comes in Xamarin Forms. It's pretty easy to build a pub sub mechanism if you're not using Xamarin Forms. Plus, Xamarin Forms is open source now, so you could always take a look at how the messaging center is actually implemented and do something similar. So for the things that are MVVM specific, we have just a single view model for our page and obviously our actual view. And like I said, we're not going to be looking at the inversion of control stuff, but for that final implementation, there is a view model locator and an inversion of control config that injects each of those different types. So when we run the app, we're going to see an empty list and some toolbar items that are going to give us some options to create a to-do item, populate it with a whole bunch of them, clear any that are completed, toggle all of them. You'll be able to delete a single item and be able to basically manipulate it, and you'll see like those little toasts at the bottom that are fired whenever a change comes down from the store. So, unless there's any questions that you want to get out ahead of time, we're going to go move over to Visual Studio and actually implement this thing. And, cool. So in Visual Studio, I have a solution set up. I've added some NuGet packages ahead of time, so you don't have to sit here and watch me reference them. But I've only added 2. I've added MVVM Lite just for the MVVM stuff because it's my preference. You can roll your own or use any of the like 30 that are out there now. And then I also added the ACR.userDialogues, which is from Alan Ritchie, which just makes it so we can create toasts and prompt users from stuff from our view models from our shared code really easily. So those are the only 2 that are added, and they're added to the PCL as well as to each of the platform projects. So the first thing we're going to want to do is create our view. So we have our main page here. We're going to clear out some of this pre-built stuff, and we're going to basically just populate it with our list that we're going to be using. So go create
Hey Alex,
a list view.
Alex, would you mind increasing your font size a little bit so we can see that better?
Yeah, I can do that. Make sure I do this right. Oh. I'm just gonna have to do it down here. It doesn't like it when I'm in my VM and try to control scroll. Is that better?
Yeah, that's a little bit better. Thanks.
Cool. Let me know if anyone needs it any larger too. So we're going to give this our item source, which is just going to be from an observable collection in our view model called items, and that's basically all this is going to actually need for its initial properties. So now we can create our item template. And we're just going to use a basic text cell for this. That looks good. I'm going to leave some room here for when we want to actually add those inline actions. Another thing I'm going to do real quick is actually give my list view a name. because I'm going to need to reference it in order to bind the commands the way I want. So we're just going to call this to-do list view. So that's all we're going to need for now. We're going to start off by just getting some items in a list. And what we're going to need to do now is create our model for our to-do item. So I'm going to go ahead and create a folder, models, create a new class.
And Alex, sorry to interrupt again. So the dark theme doesn't seem to come through on GoToWebinar very good. When you get a second, finish your model class, but would you mind switching to the light theme in Visual Studio? It definitely pops a lot more with the font on the light background.
Okay.
Thanks.
Yep. All right, let's just create this, and then we'll go into our options here. Let me see if I can even remember where this is exactly. There we go. I can't even remember the last time I used the light theme.
Yeah, dark theme's great for actual development, but not so much for presenting.
Yeah. Okay. Does that look any better?
Yeah, it's definitely easier to read. Thanks.
Cool. So this model is also going to need to be observable so that we can handle automatically updating, or like when we remove an item, or mark it as complete. So because we have MVVM Lite, we're going to have this inherit the view model base. Pull in our namespace. Cool. So I have some pre-built shortcuts, which are nice for these bindable properties, but otherwise you're really just going to have to type them out. But our to-do is just going to have 3 fields. It's going to have an ID, a text field, and then an isComplete field. So, oh wait, no, I don't. So we're going to have a private string ID, private string text, and private bool isComplete. All right, so now we're going to need to make the actual notifiable public properties. And one more. Cool. So that's all we need for our model. Now we can go ahead and create our actions, or I should say basically our action IDs. So I'm going to create another folder called action types. And this is really just going to be, I'm going to namespace it to my model, so I'll have like to-do action types. That way we can separate the actual names of these events to things that are applicable to basically the domain of each of our different models. So we're going to have some IDs here for things like we'll say item added, item deleted, item completed, and we'll leave it there for now. We'll be able to go back and create some more of those specific ones. So the next thing we need.
Hold on a second. So hey Alex, we had a question here. If you go back to your view model, you're using the set method. Is that part of the base class, or where are you getting?
That's something that MVVM ships with. So basically, what the set method does is actually apply the change from the value to whatever your private field is, and then it's going to fire the notify property change based on this property name.
Great.
So it's just a nice shortcut that the view model base gives you.
Right, and that's coming. The view model base is coming as part of this Flux package.
It's coming as part of the MVVM Lite NuGet package.
Oh, the MVVM Lite. Okay, great.
Yeah.
Second question.
Sure.
So back to your constants you just had there. Question Stephen asked, why not enums there as opposed to constants?
I mean, I guess you could use an enum. Well, actually, I take that back. Sorry. For this sake, we do need strings because these are going to be going through the messaging center from Xamarin Forms, and the messaging center expects a string to be passed through for the message type. So you could use an enum and to string it there, but this is just going to be a better visual for that.
Great, thanks. And you did say all of this code that you're writing here, is this all available on GitHub?
Yeah, it is.
Yeah. Okay, so you're going to be sharing that later. Excellent. Thank you.
Yep. So let's see, where were we? We're going to go in and basically create our store structure. So for the sake of this setup, I'm going to create a base store that's going to be able to handle subscribing to certain events through the messaging center, and then also handle emitting the events that it's going to take after receiving them back down to the view. So we're going to need a unique event args type for that emit so that the views know what events are coming down. Then we're going to set up our base store. Then we're going to set up our actual store for our to-do items. So I'm just going to put this all under one big folder here called stores. Sorry, my Visual Studio does not like when I'm on GoToWebinar. And we're just going to give this some properties that are relevant for events coming down, which is really just the name of the event that's being emitted. So it's just going to have, we'll use prop here. And then I'm just going to make a constructor to add it a little more easily and leave our default there. Cool. So now let's go create our base store. Our base store is going to handle the actual emitting of events back down to views that subscribe. It's not going to actually implement any logic of receiving the events, but it will wrap the messaging center subscriptions and stuff. So it's a little more, it's a little easier for our actual store implementations to subscribe when they're created and stuff like that. So the first thing we're going to need to do is create the actual event handler based off of our new event args. Oops. We'll call it onEmitted. I'm also going to make this generic so that we can have a base property for the actual data being stored. So we'll have type T, we'll just call it data. And then another useful thing for stores to do is also keep track of errors that might have happened. So there's a lot of kind of debate in the Flux community on how exactly to handle your stores, how to separate them and whatnot, how to handle errors. Some people will take the approach of having unique stores to handle their errors. So like if we had a to-do store, they would also have a to-do error store. And then their views would listen to both those stores. And then the actions would handle which event type they fired through the dispatcher based on whether something went wrong or if the actual data should be updated. My personal preference is to just keep errors that are relevant to a certain model or a certain domain in the same store that the data lives. So we're just going to have a property here for the most recent error. But you can get as robust as want with that error tracking. So now what we're going to do is have that emit event. So that's going to be something that each of our stores ends up overriding. So we're going to want to make it protected so they can have a reference to it. And then this is just going to take the event type. And then we'll call onEmitted. And now we can handle subscribing to our messaging center. So we're going to have another virtual void subscribe. So we're going to need two of these because some events that fire from the messaging center don't actually have data attached to them. They're kind of a fire and forget with nothing. So we're going to need to be able to subscribe to specific data types to take that data in, and then we're also going to need to subscribe to empty ones. So we're going to have two overloads here. Bring in the Xamarin Forms namespace. We're going to call subscribe to, right now we'll just call this object, and then the expected type back. The subscriber is this. The string message, like I was saying, for why we don't use enums, this is the message type, so that's going to be the event type that comes down. And then I'm going to leave this empty right now, but basically for what we actually use to call back when the data is sent in. So I'll leave that there until we actually handle our receiving an event. So when we receive an event from an action, each store is going to need to update its data in a unique way that's particular to its data set, and then it's going to emit that event down to the user by calling our emit here. So what we're going to do is create another virtual method here just called receive event. And it's going to take the event type and the actual data that's sent into it. So what this base class is going to do, or I'm sorry, what this base method is going to do is just fire the emit with the event type. So the intention is that each of our base stores, or sorry, each of our unique stores is going to override this, then after updating its data, call this base method here. And so that's exactly what this is going to call for its subscription callback. That's going to be the event type and the, oops, sorry, this should be an action. Sender, data, and that's going to take data. Cool. So now we'll make our no data override for our overload for our subscribe. So now for a received event, when it doesn't have any data, we're just going to return null or send null down to our receive event. Sorry. Cool, so that's basically it for our base store. Now we can go and implement our actual to-do item store here, if it will stop lagging on me. So the data that's going to be in our to-do store is going to be an observable collection of to-dos. Nope. So I'll have to bring in both these namespaces. So now in our constructor, we can handle what events are actually being subscribed to from our dispatcher. So we know that we created action types for adding a new item, for deleting an item, for completing it. So we're going to go ahead and subscribe to those events from here. Do action types, item added, item deleted, oops. So we're passing in a string for item added because we're going to just be adding it based on the text that we get from our dialog. And then for deleted and completed, the string that's passed in is the ID of the to-do item, which, as you see, is a string here. So that's why we're passing in those specific types. That's what our store is going to expect to get from our dispatcher, and that's what our actions should send when they actually fire to the messaging center. So now we're also just going to set the data to a new observable collection, just so we can avoid some null reference errors and stuff like that. Cool. So the last thing we need to do in our store is actually handle how we update our data when we receive one of these events from the dispatcher. So the only thing we need to override right now is our receive event. And like I said before, the base receive event is what actually just calls emit. So we're going to want to make sure that we are updating our data before we emit it down to the view. So that base receive event is going to be the last thing we call. So what we can do now is just switch on the event type that comes in and update based on what the actual event is, and then we can also cast the data to what's appropriate. So item added, I'm just going to get these all written out, and then we'll update them accordingly. Another thing that's a good practice to do in this switch is also set a default to create that error. So if we are receiving an event that we have nothing to do with, we might want to set our error to say something like unknown event received, just so we know that there might be some sort of hole in the way we set this up. Maybe we're subscribed to things we really shouldn't be, or something like that. Cool. So now we can actually apply the changes to our data. Right? So we can say data, which is our observable collection, add new to do. I'm just going to set the ID to a new GUID. And to string it. And then the text is going to be the data that comes down. We can implicitly cast that to a string. And then the is complete is obviously false since we just created it. Cool. Our item completed, what we can do is go and find our items. So we'll say item to complete. And we'll just use some short link query here. Call first our default, where the item ID equals the data as a string. And then we can just take that item, or we should add a null check here. If item to complete is not null, then we'll just set the is completed to true. And then we can basically do the same thing here for the delete. We'll find it by its ID. We should say data.remove item to delete. Cool. Any other questions so far? I know I might be typing fast or moving pretty quickly. I just want to know if anyone has any questions about basically the setup of our store, since this really is the core of the entire structure.
Not yet. So you went through a lot of code to get to the point where you're doing the to-do store, but so if I'm understanding correctly, all that stuff you did beforehand is all just setup that you would do once at the beginning of your project. And from now on, as you add more data items and view models and things like that, then it's going to be basically what you're doing here in the to-do store. All the rest of that is just a one-time thing. Is that correct?
Yeah, so setting up your base store, this is going to be really helpful for managing a lot of the complicated stuff that's actually the core of what Flux is. So handling, subscribing to the dispatcher and handling emitting the data down. This happens one time a year. So that's why when you create more stores for different data types, you'd see that it's really simple what this is doing. It's picking the events to subscribe to, and then it's just handling how it changes the data based on those. So you can add more and more stores, and this is really as complicated as your individual implementations are going to get. I would say that one of the downsides of using Flux is that it can get complex to start up, but time spent up front is going to be far more valuable than time spent trying to chase your data around. So there is a lot up front. I personally think that in a lot of cases it's worth it. So we have our stores, we have the types that we're sending down. What we need to do now is actually create the actions that will fire the dispatcher. And after we do that, we're going to create our actual view model for our page, which we'll set as the binding context for our page. And then we'll update our view to add some menu items to those to each of those list items for our to-do. And then we'll basically be able to kind of tie all of it together. So what I'm going to do now is actually create those actions. So the first thing I'm going to do is actually create kind of an empty interface. This could be an abstract class or a base class or anything like that. The reason we do this is because we're going to need to go back to our base store and update that subscribe, because the Xamarin Forms Messaging Center expects an explicit type for what the sending type is, if that makes any sense. So we're going to have an iActions here. And this really is just going to be an empty interface that each of our data-specific actions are going to implement. So we can go to create to-do actions. Make sure this implements iActions. And then in our base store, for these subscribes, you can see we used object at first. But in order to be explicitly safe, we're going to set this to iActions so that our stores know wherever these messages are coming from, they should always be coming from something that's an iAction. So now in our to-do actions, we're going to just create some super simple methods that are just going to fire into the messaging center. So we'll create the ones for those different event types for add, delete, and complete. So we'll say public void add. This is just going to take the text of the message that's sent in. Messaging center, pull in the Xamarin Forms namespace, and then we're going to just call send with our types explicitly set. This is obviously the sender. The type here, the message, is going to be our to-do actions type, that item added. Come on, there we go. And then the actual data sent in is just going to be that text. And we can apply the same thing to delete, except these are these now. So that's all there really is to our actions for now. This is something that grows a lot when you have a lot more things that can be done to your data types. But because we're sticking to this simply because we don't have the time, all this is doing is calling to the messaging center. So you might have things where maybe you need to actually create a model. Maybe your store is expecting an explicit model to come down. They don't always have to be simple types like string or int or anything like that. Maybe this goes and calls to another service, and then when it's complete, it fires to the store to go update its data. I know some other people have had preferences with Flux to not have the actions talk to any other services, but to have the store actually go call to the services when it receives an event. Either of those, this still, the same thing really applies. So we have our actions, we have our dispatcher, we have our store. If we were to think about that diagram that we had earlier, the last things we need is the actual view model for our page, and then we need to update our view to actually call to that view model. So in our models, I'm just going to create a to-do list page view model. So this is also going to inherit the view model base, which is, again, from MVVM Lite. And then this is going to have those properties that are going to be applied right to our view. So we're going to have our observable collection of our items, but rather than it being separate, we're just going to be able to pull down from our store. It's also going to have a reference to our store and a reference to our actions so that it can subscribe to the emitted event. And then the commands for create, delete, and complete. So give me a second to type all this out. So because this is a really small example and we're only using a single view, I'm just going to new these up in the constructor of the view model. If you go and look at that completed source, you're going to see these are actually injected into the constructor. That way multiple views can actually reference the exact same store. I've seen some other people do it by basically just having a static reference to that store live somewhere like in the app class or something like that. But in order to keep ourselves using our time wisely, we're just going to do it this way. Although I really would not suggest doing this in an actual implementation. Actually, I should take this back. We don't need this. I'm also going to use the relay command here, which is also from MVVM Lite. You can also use just the baked-in command from Xamarin Forms or whatever other commands you're actually using. But basically, all these are going to do is call to our actions and apply the appropriate thing. So I'm going to leave these empty for now and just get them all typed out. And it missed a semicolon. So what our create's going to do is use that other NuGet package that I talked about, the user dialogues from Alan Ritchie. And so it's just going to prompt the user to create a new one, then take the text from the dialogue, and then fire that to the action. Also, this is going to need to be async. These other ones are even simpler. These relay commands do need to take a command parameter for the to-do item that we want to complete or delete. So we'll call this to-do. But these are really just going to call the actions. And then we'll do the same thing down here to the delete. Oops, I forgot to get there. Awesome. So that should just about do it for our actual page model. Again, so if you remember back to when we set up our view initially, we set the item source from our main page to our items. This is just going to pull the data directly down from our store. One last thing we do need to do is actually show how to handle updating based on when items events are actually emitted from the store. So let's go take our store from our constructor after it's been created, and then we're going to take the onEmitted and create a new event handler here. So similarly to how we switched on the event type in our store that it receives from the dispatcher, we're going to also switch on the event type that comes down from the store. So if you had a view with a whole bunch of different properties, like something like a profile page that had a user's name, email, their image, and a whole bunch of other info, when that user's info is actually loaded into your store, you can take those different event types that are emitted here and then update those properties that are bound in this view model. In this case, we kind of have it easy with our observable collection coming right from our store, but just to show how it works, I'm just going to basically show a toast based on which type of event actually comes down. So we'll bring in our to-do action types again. So on item added, we're going to use our user dialogues again. We'll just say item added. And I'm just going to copy this for the other two. Item completed. And item deleted. So now we need to go back to our view, and we're also going to need to open up our code behind for our view to set our binding context. So we'll set the binding context for the page to a new to-do list page view model. So we need to add a toolbar item, and we need to add our menu items for our list item. So we'll go ahead and add the create item up here. Say content page, toolbar items. And the command command is create command. And then down in our text cell, we'll add our context actions. Say delete. So this is where this is why we gave our list view a name here, because we want our menu items command to actually fire to our pages view model rather than to the actual to-do item itself. We're going to set a binding here based on the binding context of the list view, which is that list view page view model. So add x reference to-do list view. Path is that list view's binding context dot delete command. And then the last thing we need, I'm going to separate these on different lines just so it's easier to see on one screen, is our command parameter, which is going to be the actual to-do item we're working with. So we'll just set that period there, which means this binding context. So we can just copy this and apply it to the completed as well. Except this is non-destructive, and we're going to use the complete command. Awesome. Didn't like my formatting though. Also not sure why I'm not connecting to my own Mac right now.
Give it a minute. Also, try IP address. IP address usually works better for some reason.
Okay. I'm going to back here, and I'm just going to pause my screen here real quick while I go grab my IP address. Apologies for the technical difficulties. I'm actually getting just a blank red error whenever I type in my password and username. But what I can do is I can open up the simulator and run the app that basically we're copying from anyway, because I should still have it loaded on here, so you can still at least see it in action. So we can load this up. This is the actual output from the solution that is up on GitHub, which is what we're basically copying here, but with fewer functionality. So in our create here, we'll just call this hello XAMU. So you see our item added propped here based on the event handler in our view model, and updating that data by adding it in the store propagated right down to our view here. So from here we can also work on some of our context actions like deleting it. And to show you some other examples, we can populate it with a whole bunch of fake data, toggle it to completed. You can see the toast down there and the actual item updating right away. Yeah, so that's our final solution. I'm sorry we couldn't actually run the code that we just spent all that time writing. I'll have to figure out what's going on with my Mac right now because it was connected earlier. Are there any other questions or anything you guys want to see in the app, or any other quick code you want to write?
So we had a question earlier, and I don't know. Have you worked with reactive extensions before?
Yeah, I have in the past.
So we had a question. A lot of what you're doing with the base store and things like that seems very familiar and very close to reactive extensions. Would you be able to compare maybe Flux and RX?
Yeah, so those extensions. So the reason why Flux is also cool is because it can keep your solution real slim. We were able to build something similar, or at least that kind of unidirectional flow, the same way that you would get with those reactive pieces. But we're able to do it smaller, and we have a little more wiggle room. I haven't played enough recently. I played with the reactive stuff when it first, started to come out. I don't know if anything's really changed. But the big thing for me with it is that it's similar in that it has that unidirectional data flow, right? So that is one of the big advantages. But in this case, sorry, just reading through some of these questions too. For the case of Flux, is that there's also a huge community around it, and there's people trying to push toward even more standards that are going to help you build out those robust apps. So although there isn't a community with Flux and Xamarin, there is a gigantic community around React.js, and because React.js is basically shipped with the purpose of using that Flux design pattern, there's a huge advantage to that community. And I know when I was first learning it, I did learn it with React.js at first, that having that big community is also a big plus. But yeah, I mean, the general unidirectional data flow, it's the same thing with those same advantages.
Great. And then another question here is, so a lot of various frameworks impose things like a particular data store. So do you have freedom?
Yeah.
You can pick whatever data store you want, correct?
Yeah. So really what we were looking at today was just a really agnostic implementation. I used MVVM Lite for my MVVM bindings. But from there, you can use anything you want. If you want to do local store with SQLite and stuff like that, you can have your store directly communicate to some sort of repository class in those or other service implementations that maybe your actions call. So that's like one of the big points I pointed out at the end of the deck was that it plays really well with some of those other patterns and using those other tools. Its big purpose is mostly to have that really robust data-driven UI. So it's agnostic to what's actually going on in the back end of it. All it cares about is how data gets down to the UI and handling, like, tracking where that goes.
Okay, so you could use SQLite, you could use Realm, you could use Couchbase, you could use Azure Mobile, whatever you want there. Fantastic. So this is a really good question. Dimitri's got a great question here. We saw all the cool stuff with Flux, but what are some of the potential disadvantages or the complexities versus other patterns that might achieve something similar?
Yeah, so some of the disadvantages are that there aren't strictly defined rules yet on the exact roles of where business logic goes. So we didn't run into that in this case, right? Because we're looking at a super simple example of just a list of data and applying some changes to it. But like I said, when we were going over writing out our actions, some people push that action should make calls to services and do a lot more business logic. Then the stores are really just responsible for changing data and firing those events down. Other people say that the action should basically just proxy to the dispatcher. The store should handle when that event comes in to go do all of the business logic by calling to like a service or something like that, and then handle updating its data. So another disadvantage I would say is that if you don't handle your event registration properly, you can end up with memory leaks. So we didn't have to show it in this situation because we're not changing pages, but if you're going to actually implement this, one thing you need to also handle is unsubscribing from the messaging center and unsubscribing to the emitted event in between your view and your store. So if you have that event handler there and you're digging deep multiple pages in, you're going to be adding more and more and more event handlers and other things like that that aren't relevant because that view is not visible to the user. So one thing I suggest is if you're looking at Xamarin Forms, for example, in your like on disappearing override in your page, go disconnect the event handlers that aren't relevant to it, and then on appearing, go reconnect everything. If you've ever worked with React.js, that's similar to subscribing in the component will mount and unsubscribing in the component did dismount, which is a very common practice there. So that's why when I tried to make that comparison earlier to those React.js parts to the Xamarin parts, if you're familiar with Flux and React and you know where you're handling your events so that you're keeping your memory clean, you can apply that same practice. But if you don't keep track of it, it can get ugly.
Yeah, and that's definitely a good tip for really anytime you're using any kind of event or subscribing or anything in .NET, whether it's Xamarin or not Xamarin or anything, is always make sure you're unsubscribing from those or you're going to have problems. Definitely. Can you put your slide back up, by the way, your title slide, so everybody can have your contact information? And
yeah, let me just open it up real quick.
Does
I closed it trying to clear out for the simulation.
Does that have the URL to the GitHub project as well?
Yeah, it does. That's in the resources. So let me get both of them up. So I see a question asking for my contact info. So here's my basic contact info. There's a link to my blog at alexdunn.org. There's also my GitHub handle. So if you want to see all my repositories, you can go to github.com/swabpirate, all one word. And my Twitter handle is swab_pirate. Just note the difference. As for links to the actual pieces here, so here's the initial project, which is what we started with today. So it's at my GitHub/XAMU. And then the completed project is under my GitHub, and the repository name is xamarin.flux.
Excellent. And when I put this recording up on our website, it'll be under the guest lectures section, and I'll have a link to materials there as well. So
sure.
If you're anybody who's looking for all these materials, just come to the Xamarin University website. You'll get the video and all these links and everything else as well. So you have one place to go look for it all. It's kind of funny that somebody already had Swab Pirate without the underscore. What are the odds?
Yeah. It was frustrating because I had already committed to it for my new handle a while ago, and I guess some like kid took it or something.
Nice.
Interesting.
And then last question. I had a question about what are you using for those pop-ups that popped up at the bottom of the application?
Yeah. So that would be the user dialogues plugin, Alan Ritchie. So it's a NuGet package here called acr.userdialogues. So in our view model, when we handle an event coming down from the store, you can see here we were calling userdialogues.instance.toast. So that toast is what's actually popping up that little overlay at the bottom.
Great. And then the user dialogues package is available on NuGet. It's got lots of different stuff in there for different types of dialogues. Definitely go check it out. It's ACR.
Yeah, it's also open source too.
Right. So it's just acr.userdialogues.
Yep.
Anybody's looking for it. And I assume you're using that in the sample app on GitHub, so if anybody goes and looks at the code, you'll be able to see how it's used also.
Yep, exactly. So that empty project ships with those NuGet packages already installed too. So if you do want to fork that XAMU repository for this project, you can do that, and these will already be installed for you.
Fantastic. All right, so let's see. Does anybody have any other questions on anything before we end our guest lecture? So if you do, make sure you put them in the questions area there. Anybody can send me an email or Alex an email as well if you have questions. And like I said, we'll all have the video and all the materials up on the Xamarin University website. And then lastly, as I said at the beginning, I'm always looking for more guest lecture speakers and topics. So even if you don't want to speak yourself, if you have something you'd like us to cover, please let me know. I'll do my best to find somebody who can present on that. These are a great way to expand our curriculum and expand your knowledge as well. All right, doesn't look like we have any more questions. So Alex, thank you so much for your time. I really appreciate it. It was great, very interesting architectural discussion. And hopefully everybody has a great day. And we'll check you out at the next time.
Great. Thank you, guys. Thank you so much for joining.